Hi and welcome to this new section of the course, and in this section starts the real deal. So in this section we're going to develop the first application of the course. Until now you went through the basics of Python, you learned functions, loops, conditionals, and handling files, etc. And now we're going to practice all those concepts by actually building real programs that can be used by users, instead of just looping through trivial strings and numbers and so on. And so what are we going to build in this section? Well, you're going to build a program which you can give a word, an English word, and the program will return the definition of that word in English. So let me go ahead and demonstrate the program. I'm using Python 3. app1.py is a script. So the program asks you to enter a word which you want a definition for. For instance, let's say mountain. And so you get the definition for mountain, and in this case it happens to have two definitions. So a mountain is a feature of the Earth's surface that rises high above the base. And also mountain has another meaning, which is a great number of large amount of things not placed in a pile. Anyway, there are words who have only one meaning, like mathematics, I hope, yeah. So you get only one definition for mathematics. But also, the program has other features as well, such as, if you put rain with double N, so with an extra N, and press enter, the program, instead of crashing, it displays a message. It tells you, did you mean rain instead? So it's quite an intelligent program that guesses the word that the user may have had in mind when typing the word. So enter Y if yes, if you meant rain, or N if no. Oh yeah, I meant rain, so Y. And you get the definition for rain, which happens to have two definitions. This is the first one, this is the second one. The program also, if you enter a very random word that doesn't have any meaning like that, you get the message the word doesn't exist, please double check it, because the program cannot find a similar word to this. It cannot find a word first, and also it tries to find a similar word to this one, but it doesn't, because I don't think there's a match for this, and so it prints out this message. And there's also other things like, if you have mix of letter cases there, like uppercase R and A, you still get the correct input there. So that's a program. It has a command line interface, which means you're passing the input through the command line and you're getting the input again from the command line. However, later in next sections, I'm going to explain you web applications, how to create web applications with Python. And so you then may get back here and actually create a web application using the code that you will be learning in this section. So you can extend this program to make it more user-friendly with a web interface where the users can enter the input through a web form, through a web page, and then press a button and then get the output on that web page. However, the code that you'll be learning in this section is very important. It's core Python, so you're going to learn about conditionals and loops. So you're going to implement all those that you learned in the previous section by developing this program. So I hope you like this, and I wish you success. See you in the next lecture. Hey, hi again! In the previous video I did a demonstration of the program so that you know how the program looks like and what is the output that the program generates, and also the interface of the program, which is a command line interface. So you input the data through the interface, the user inputs the data through the command line interface, and you get the output again from the command line. Now I have created a folder here somewhere, and I have give it a name. You can give it any name that you want, and inside this folder I'll be putting all the files of this project. So we're talking about the data files, like data.json. This is a file that contains the vocabulary where the program will extract, so we'll ask for a word, and this file has the definition of that word. And also the .py files will be put in here. So we know the output, now we need to figure out the way how to go to that output, and we will take the approach step by step, which means that first we're going to develop a simple version of the program, just like give the program a word and the program will return the definition of that word. But this will be very simple because, the user sometimes they may pass a word that doesn't exist, and as a programmer you need to count for that word, for that not existing word. So instead of interrupting the program, showing an error to the user, you need to show a more user-friendly message to the user. And we'll do that in the next videos, but for now, the very first thing we need to think about is the data. So I did some research on the web and I found this dataset of words and definitions. Now this is around 5 megabytes of data, so in Atom it takes a while to open, so I clicked it and I'm still waiting for it to open. Now it opened. So if your Atom freezes, then you can open this with a more lightweight editor such as Notepad or Nano on Mac or Vim. So anyway, this is a .json file. So what is JSON? JSON is like a language. Some say it's not a language, it's just a set of rules how to format some data. So JSON follows this format. It starts with a curly bracket, and then all you have is pairs of keys and values. So this is like a Python dictionary. So the key is separated by the value by a colon. In this particular case, our values are inside square brackets, which suggests that sometimes you may have more than one item inside the brackets. For instance, let me search for the word, Control F or Command F, rain. So that will take us in here. First, let me go to View and toggle Soft Wrap. So what that will do is it will fit the text inside my screen. So for the moment, you see precipitation is outside of the screen bounds. So look, this also takes a while because we have quite a lot of data here. Now the data looks better, so let me search for rain again, find. And so this is the key rain, or let's say the word rain, and this is the definition of the rain. And in this case we have two definitions because for some words you may have more than one meaning, or you have more than one form. For instance, this is the noun, rain as a noun, so it's a precipitation, and this is the verb for rain. So when it rains, to fall from the clouds in drops of water. So it's a verb and a noun, and they are separated by a comma. So this is just like a Python dictionary. And now we need to figure out how to load this data into Python. Because to access data from this file, you first need to load it into Python as a specific Python data type. And then you access data from that data type. So think for a moment what Python data type would be more appropriate for this JSON file. So think about that, and I'll show just that in the next lecture. See you there. So I believe it was quite easy to realize that the best way to load this data in Python is a Python dictionary. So this looks just like a Python dictionary, and once you will load it in a Python dictionary, then it becomes very easy to access a value for a key. So how do we load this into a Python dictionary? Well, let me open a command shell here. For now, I'm just going to demonstrate something quick in an interactive Python shell. But first, you may need to close this JSON file because this is slowing down Atom. Don't say the changes, I didn't do any change anyway. So Python 3, that will open my Python 3.6.1. But anyway, even if you have Python 2, this program will work the same. So how do we load JSON into a Python dictionary? Well, for that we need to use the JSON standard library. With a standard library, it means that you don't need to install JSON, you just need to go ahead and import it. Once you do that, there is a nice JSON.load method there. And this load method, this expects, actually, I can show it like this, help JSON.load. So this gets this argument here, which is a file-like object that contains a JSON document. So we're talking about the file object in Python, and we need to create that file. And the way to do that is simple. So JSON again .load. The way we create a file object is by using the open method. You know that already. And then you pass the path to the file. Now, since my terminal here is pointing to this folder, I just need to pass the file name. I don't need to pass any full path in there. So like that, you can either pass the R method, which is stands for read mode, or you can just leave it like that, and the read mode is by default. Make sure to close brackets 2 times, so we have 2 opening brackets here, 2 closing brackets in here, and that's all. Now, what is data? Data is a dictionary, so it's a Python dictionary, and you can print it out. Yeah, it's quite a lot of data. So that took a while, but normally you'll not have to print out the entire dictionary. What you could check is to access a word and a key from the dictionary. Let's say the key rain, you need to use quotes for the key. This is what you get. So you get the value for the word rain, for the key rain. So now that you know how this works, more or less, try to come up with a function that gets as input a key and then returns the value for that particular key. And also try to incorporate the loading of the JSON file and also print out the output. So if you have issues with that, in the next video I'll show you how we do that. See you there. I hope you figured out how to create a function that gets a key, so a word, and it returns the definition of that word. So let me quickly build that program. Let me call this app1.py, import JSON, data equals to JSON.load, open data.json, that's it, and define the function translate. Let me call this translate word, and yeah, all you have to do is return data word. That's it. And then you can either let's say you can either do something like word equals to rain, or you can do this dynamically by asking for input from the user. Enter word like that, leave a space, and then all you have to do is print out the output of the dictionary, because you know this dictionary for now it just returns a string, but you are not printing any output. So if you want to show that output in the command line, you need to print out translate word, and that's it. Now, don't get confused with these variable names. This is a global variable, and this is also a global variable. So we define the variable here, and we pass it here. And then this, whatever is passed in here, goes to this one here. This could be a different word, a different variable name. So let's say W. So this is a local variable. It has a meaning inside the function, and it can be everything. So if you pass W here, it has to be W in here too. and this passes this value into this value in here. So usually programmers, they prefer to just enter the same name here and there, but for you as a beginner, I wanted to show you this difference, that this doesn't have to be the same with this. So save the script, maybe open another terminal, python 3 app1.py, execute, enter a word, rain, and this is the output. How about this word? Oh, we got a nasty error there. But you don't want to show that to the user, right? Because this is not very readable. Trace back most recent call last. Okay. So how do we count for this scenario in our code? You need to figure that out. So think about it. In the next lecture, we'll do just that. So we need to take into consideration that word that the user passes may not be in the dictionary set of keys. So rain was a key of the data.json dictionary, but this name here was not, so we need to count for that. I'll show you that in the next lecture. See you. Alright, let's go ahead and make this program more user-friendly. So instead of showing this block of error, we're going to show a message that says the word doesn't exist, please double check it, or something like that. So the way to do it is, let me go to the Python interactive shell. You can check something like that, rain in data, and you get true. If you do this in data, you get false. So we need to make use of this and say if word in data, sorry, this has to be w, we're talking about this variable, and so if w in data, what you want to do is return the value. So this is the value, and so if this returns true, this is executed, right? Else return the word doesn't exist, please double check it. So when this is false, then else is executed. This actually the expression under else is executed, and this is not executed. As you see, this is quite readable, very human readable. This is the good, one of the great features of Python actually. And so I can save this now and go here, execute the program. Rain would work as before, and this says the word doesn't exist, please double check it. So as easy as that. So the program is taking shape. However, you need to do more tests to check for different inputs, in order to take into consideration every possible input that the user may put there. So let's say the user puts rain in uppercase letters, and this says the word doesn't exist, but actually rain is a word that exists in your data set. And so how do we count for different uppercase letters? You also may have like mixture of letters like that, and it still says the word doesn't exist. Or even rain like that, the word doesn't exist. So think about that again, and in the next lecture I'll implement that, which is very easy. See you there. Great, we have this program now that returns a value from a word that we put. So it returns the definition of that word, and it also counts for non-existing words in our dataset, which is data.json. To count for different cases of letters that the user may input, you may look at the dir str should show you the methods that you can apply to a string. And here is there's a lower method, and what that does, is if you put rain there, It's so the method should be applied with brackets. You get rain, so the lowercase version of the letter. So since our data are all in lowercase in our data.json file, then what you do is, as soon as you get the input here, the string, you can convert it to lowercase, and then you pass that version to the dictionary access expression in here. So that would be something like, you know, w equals to w.lower. So we are updating the w value here, the string that the user inputs, and then the w here will be passed as lowercase. So as easy as that. Let me do a quick test. Rain, and you get the correct definition of rain. So let's think about more possible values that the user may input. Let me clear the command line so you see better. Let me call the program again. Weather works fine, but how about instead of putting rain, the user types in an extra n there. The program says the word doesn't exist, which is true. But as a programmer, you want to make your program as more intelligent as you can. So in that case, you may want to consider checking for strings that are similar to what the user input. You know, rain, you need to check if there is some string that is similar to this word. And instead of saying the word doesn't exist, you want to suggest the user that, oh, well, maybe you meant this word, you know, similarly as you do a search on Google. So that's a bit complex, but not that much. And I'll show you how to implement that in the next lecture, step by step. So see you there. Good. As I mentioned previously in the previous video, now we need to take into consideration when the user mistypes something. So instead of rain, they enter an extra n there or something like that. And in that case, you want to let the user know that they typed something wrong there. So how do we do that? Well, if you have no idea how to do that, the best practice is to actually do some research on Google. Because, you know, the world of programming is very wide, and you don't necessarily need to know every possible workaround or solution to do something. So basically we need to figure out an algorithm to compare, let's say, the word rain with double N and the actual word rain with one N at the end. And say that decide whether these are similar or not. But you don't have to reinvent the wheel if someone else has done it already. So that's why you need to do some research on the web and see if this is something that, if there is a library that exists there, or someone has a source code that does it, a function or something like that. But usually, often you find a library for that. So if you do some research, you realize that you can do that using a few libraries, and one of them is a standard library and it's called difflib. By the way, you can get a list of Python standard libraries in this page. So python.org, library index.html, this is the link. Here are all the standard libraries that you can import into Python. So let me go here and import difflib. So this is a library to compare text. And one of the methods is sequence matcher. It's a long name, so what you can do is say from difflib import sequence matcher. What that does is sequence matcher, you need to pass none there, None is the value for the argument isJunk. So the first argument is an argument called isJunk, which means that, if you're comparing two blocks of text, in this case we're just comparing words, so if you're comparing two blocks of text and you have some junk there, you have like break lines and spaces, then you need to pass here a function that ignores those lines. We don't have that scenario for now, so let's keep it simple. We pass null there for that argument, and then you pass it to strings. So you want to compare the word rain with a double N against the actual word rain, and that will return a sequence matcher object, which is nothing interesting, so you need to apply the ratio method to that to get the actual ratio. So this indicates a similarity between these two strings in a scale from 0 to 1. So they say that these are quite similar. Now this is about getting the similarity between two strings, but what we need instead is basically we have a list, a sequence of strings. So we have these keys of dictionary. We have a dictionary with lots of keys, and the user passes a word, let's say rain with double N, and you need to compare that word with all those keys of that dictionary, because you cannot compare rain with double N with rain with one N in your program, because you don't know that this is actually similar to this. So it's the reverse problem, so to say. But difflib has another feature for that, and it's called get close matches, like that. So you need to import that from difflib, import get close matches, but I'll consume this feature in the next lecture. See you there. So we looked at the sequence matcher class, which returns the ratio method of this class. It returns this number, but now we need to see how to get the most similar word out of a list, or out of the keys of a dictionary. So let's focus first on a list, on a sequence. So a list is a sequence, and from difflib import get close matches. Now if you do help get close matches, you can see the arguments that you can pass to this method. So the first one is the word, so that will be the word that the user passes, and then you have a sequence of possibilities. And so what is a sequence for which close matches are desired? Typically a string, so typically this will be a string that you want to compare. And possibilities is a list of sequences, or a list of strings, you can say. So typically it's a list of strings. And then you have n equals to 3. That will define the number of the matches that you want the get close matches method to return. Let's say you pass a list of possibilities with 6 items, and each item has that ratio, so from 1 to 0, from 0 to 1, and this method will return the 3 most similar matches, the most similar strings to the word passed in here. You can change that argument value if you want, and you have the cutoff. So that's the ratio here. By default, this will return only those items that have a ratio of at least 0.6 or greater than that. So under that, the matches will be not included. Q to end the help, and get, let me try, close matches. Let's see what we get. Let's say rain, and then you have a list in square brackets, of course. Let's say help, pyramids, and rain. And I'll leave the n and the cutoff as they are by default. And so In this case, you get rain. The reason you get rain is because rain had a cutoff of greater than 0.6 or similar to that. If you're interested about the cutoff, you can use a sequence matcher, but we're not interested in that, in the specific value. So rain was the only one who satisfied those conditions. So we get rain here as a list. So, okay, we are able to get the close match out of a list, but how do we get the close match out of our dictionary keys? Well, we still have a data variable here, which I loaded previously here in this session. I loaded from the JSON file. So with data dot keys, so there's a method of dictionaries which is called keys, and with that you can get a list of all the keys of the dictionary. So we're talking about only the keys, not the values of the keys. So these are the words, and each of them has a value associated with it. And basically you can check the type of data.keys just to see what it is. So it's like a dict keys object, but it behaves like a list. And what you could do then is apply the get matches method. So you pass rain there to data.keys. Let's see what we get. So we got 3 matches. We got rain, train, and rainy. You know, if you pass an n of 5, you get more matches there. But it's important to note that the list here is ordered. So the very first word is the one with a higher ratio of similarity. So we are only interested in that first word. How to get that? Well, you can ignore this number since you only want the first word, and you can pass 0 there because, you know, this is a list and the first item has an index of 0. So you get rain for the rainen mistyped word. So yeah, basically we have the engine to get the most similar word out of a sequence now. And all we have to do is to implement that functionality in our function in here. So first I would just like to let the user know through a message that they have input a wrong word. So I just want to let the user know, and so that they can run the program again, so next time they input a new word. For now, but later we will do something more intelligent. So for now, just think about this. Give out a message when you mention your suggestion with the correct word that the user may have had in mind. So let's do that in the next lecture. See you. Great, the program is going well. I hope you're enjoying this. It's not a big program, so we don't have lots of code here, but however, this implements quite a lot of aspects of Python. So we're loading data in Python into a Python data type, and we have functions, we have conditionals here, we have user input, and later on we're also going to implement for loops in this code. So we'll talk about that later, why we need for loops. And so we have libraries, we're importing libraries here. And so this is JSON. We also need to import the difflib library, which we are currently working on. So let's focus on difflib for now. And what we have is, we pass this rain string with double N here. And we got a set of suggestions. So the best matches of the word rain out of the keys of our dictionary. But the user may also pass a word that doesn't exist at all, and it doesn't have any similar matches there like that. So basically you have 3 scenarios. The user enters the exact word like rain, and immediately you return data so with that particular key. That's the first scenario. The second scenario is when the user enters a word that is very close to one of the words you have in your dictionary, so like rain with an extra N. In that case, you want to return the first item of the list that the getCloseMatches generates. And the third scenario is when you get an empty list, which means that there is no such word or similar to that in your list. So we have three scenarios, which means we need to sort of apply three conditionals in the conditional block here. At the moment we have only two, so we need one more which says, did you mean this word? So please double check it. For now we just we'll just pass a message, and also note something. You may also want to pass a higher cutoff value there, like 0.8, because sometimes if this is a low like 0.5 and you pass like some random word, that will suggest you a few words which maybe you don't want. So you may want to play around with that. In that case you get an empty list. I think I'll use a 0.8 value for the cutoff when I implement it in the script here. So let's go to our code. The first thing we need to check is if the word is in data and return the value for that word. You may ask, what if you want to check for similarities first and not this? Well, I think the first conditional you need to apply is the one that you think will have more occurrences. So if you think that most of the users will enter the correct word, then you need to check for that conditional first. You don't want the program to go through the conditionals that have less probability to happen. So you first want to go through this, and then the others are ignored if this returns to true. If this doesn't return to true, if it's false, then you want to check for another conditional. And when you check for more than two conditionals, you need to implement the elif statement. So for multiple conditionals. And so we need to we need to check whether this list is empty or not. So if it's not empty, that means we got a match in the dictionary. In that case, we want to suggest that match. We want to mention that match in the message. So which means that if getClose, let me import it first. From difflib import getCloseMatches. So if elif getCloseMatches with the word given in data.keys, like that. So this is a list object, right? That's the same thing as this one here. So this is a list object, and you want to check whether the length of that list is greater than 0. If it is, you want to return a message. Let's say, did you mean? We use a string formatter here, %s. I'll explain what that is. Instead, did you mean that instead? And after the string, after you have closed quotes, you use the % operator, and here pass a variable that will replace this formatter inside this string. So this will be replaced with whatever variable you pass all the right to this here. In our case, we want to pass getCloseMatches for w and data.keys, and you want to get the first element of that list and put it here. So this is to understand it. Let's say we have a variable which has a value of 1, and you say, hey, s, like that, %a, and the %s will be replaced with 1. That's the same what we're doing in here. And yeah, that's all we have to do. Else, so if this evaluates to false, and this evaluates to false as well, then what that means is we're dealing with an empty list. So the user entered a word that didn't have any match in our dictionary, and didn't have any similar word in our dictionary. So you want to return the word doesn't exist. Let me save the script. Go to the terminal, the upper arrow key to call a previously executed command. So Python 3 app1.py, execute, enter a word. Let me start with a correct word, rain, and you get the definitions for rain. Let me execute again, rain with an extra N. And yeah, we get this message, did you mean rain instead? So the %s was replaced with the first item of the list returned by getCloseMatches. And again, if pass a very random string there, it says the word doesn't exist, please double check it. And yeah, that's it. However, I still see an issue with this, so we still can make the program more user-friendly. The problem now is that when the user enters like rain by mistake, what you say, you just pass a message there saying that, oh, did you mean rain instead? Oh yes, I mean rain, but how can I enter rain? Why do I have to execute the program again? So I'm thinking of a solution where instead of just passing a message here and ending the program, instead of that, you execute another input statement. So another input statement, another input function like that, this one in here, where you ask the user to enter, let's say, Y if they meant rain, or N for no, so Y for yes, N for no, if they didn't mean rain. So if yes, then you basically pass. You return the value for the rain word. If they pass no to the input message, then you say sorry if that's not the word that you meant, then we don't know what you have in mind. So we say the word doesn't exist, please double check it. That's what I'm thinking. And yeah, think about this, and I'm going to implement it in the next lecture. Talk to you there. Great, as I mentioned previously in the previous video, now we're going to implement an extra input, user input message into the program. So instead of passing, returning this string, basically what I want to return is an input message. So if the program finds out that the user passed a word that has a similar words in the dictionary, then you want to ask the user to enter Y or N. So how do we do that? Well, with an input function, of course. Like that. So let's add another message after this. Enter Y if yes, or N if no. So basically, whatever the user enters, you need to process that input. And that input, so Y or N, they will be basically stored in a variable, but not yet. So in this configuration that we have here, nothing will be stored in the variable. It will just be a value on the fly. So you need to store this in a variable. Let's say yn, so for yes and no, equals to that. So now either y or n will be stored in yn variable, and you need to process that variable. So if yn equals to yes, what do we need to do? So if the user meant to say rain, then we return data. here we need to pass the correct word. The correct word, we get the correct word from this expression. So get close matches will give us the best match, and we need to pass that match into the data dictionary so we get the value of the definition for rain. Because so we use that match because the user agreed that the best match was rain. So we message this will be replaced by rain, and the user agreed for that. I hope this is clear. Please ask questions if this is complicated. I'll be happy to answer you. So if yes, then return this. Let me execute this intermediate step. Oh, sorry, I use the equal operator here, which is an assignment operator. So you need to check to use the comparison operator, which is constructed of two equal operators. Save the script again and go ahead. Enter word rain. Did you mean rain instead? Enter Y if yes or N if no. Let me enter Y. And yeah, we correctly get the definitions for rain. Great. Maybe I need to improve the message here, delete the dot, and use a colon there and a space. And that should be better. If you pass rain again, and if you pass yes or no, you just say N, you get none, because you are not taking into consideration the N string. So you get none because the function is not returning anything. You know what happened here is user passed rain in here. So word is equal to rain. Word is passed in here. So this Y is equal to rain. And then we check if rain in data is not in data because it's with 2n, right? So this is not executed. The function does not execute this statement. It doesn't return the definition for rain, but it goes to this statement. And this finds a similarity. So the list is greater than 0, and then it goes and executes this. So that's why we got this another input message here. And then we continue there. So we are indenting under elif. We have another nested conditional, which is no problem. But yeah, be careful, you need to indent it. So this is one level of indentation deeper than this one in here. And so here we are. If the user passed Y, we return this statement. If the user passes everything else, then you are not counting for that particular scenario. Therefore, there is no return statement executed, so the program will end here and it will return none because nothing was returned. This will also not be executed because this is one level of indentation with this one, and since this was executed, the program never goes to this level here. So what we need to do is we need to count for other user inputs such as n. In that case, if the user enters n, well, all we can do is return the message word doesn't exist. Please double check it, which is the same as this one in here. And we need to count for another condition. You know, the user may pass Y, may pass N, but they may also pass another random string, and you don't want the program to return none. You want the program to return a message such as we didn't understand your query. And that's it. That's all you can do. Or your entry. Maybe that's better. So this is a program. Again, we have a scenario where the user enters rain, exactly, and this will be executed in that case. And the scenario when the user enters a word which does not have any match. So A is D, like CA, 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 C, something like that. In that case, this will not be executed. And yeah, that's it. Let me test the program now. Enter word rain. We get the definitions for rain. Again, enter word rain, like that. Did you mean rain instead? Enter Y if yes, enter no if no. Let me try yes. And we get the definition correctly. And rain. Enter N for no. The word doesn't exist. Please double check it. Okay, that was good as well. So we got this executed. The other scenario would be like that. And instead of entering Y and N, you just type in something. And you say we didn't understand your entry. Good. And the other scenario is when you enter a word that does not have any match at all. And in that case, this will be executed immediately. And that's it. By the way, even if you enter numbers, let's say 1, the word doesn't exist because it's not included in the dictionary. And yeah, I think our program is quite smart now. It's considering lots of scenarios there, and yeah, it's quite user-friendly, I'd say. However, there is one last thing that we can improve, and that's the way that the program displays the definitions. So when you pass, let's say, tree also has two definitions. Let's pass a word that has one definition. Structure, maybe. Oh, this has 3 definitions. All right. Pyramid. This also has 2 definitions. Anyway, you get the idea. I was trying to get to find a word that has 1 definition, but basically what you get with such a word that has 1 definition is you still get a list which ends in here, so it doesn't have a comma and it doesn't have any other items, so it's a list with 1 item. And when you have a word that has more than 1 meaning, you get this list with more than 1 items. So you don't want to show the user a list with brackets like that. The best thing to do to show to the user is, if you have 1 meaning, 1 definition for the word, you just show this definition. No quotes, no square brackets, just the definition. And if you have more than 1 definition, you only show 1 definition per line. So basically you have like multiple lines with definitions. And yeah, we need to implement that too, to say finally that our program is good and can be used by anyone, and the output is easy to read. So think about that. We're going to implement it in the next lecture. See you. Great, we have a working program now, and we added every feature that we wanted. The only problem now with the program is that the output is not very user-friendly. With that I mean, let's say yes here. So this is the output, and you get a list here. So it's a Python list. And what we want to do instead is we want to show each of these lines in 1 separate line in the terminal, so that output will be more readable to the human eye. And let's go ahead and do that. So how can we implement such a thing? So this output now is a list object, which means that the call here, the function call, this produces this list object. And so what can we do is we could maybe iterate through this list object. Something like we can store the list object in a variable, so output will be assigned this list. And then what you can do is you can say for item in the list, in the output list, print out the item. Let's save this and try out. We're going to have an issue here, but 1 step at a time. Enter Y, yes, Y. And so this is what I wanted to have. So the first definition, precipitation in the form of liquid water, goes in the first line, and the second definition, to fall from the clouds in drops of water, goes to the second line. So that's good. However, we should keep in mind that our program does not produce only the list, but sometimes it produces strings as well. So such as this one in here. No, I didn't mean that. Anyway, so this is what you get, and you don't want that. This is a message saying that the word doesn't exist. So what the program is doing, what Python is doing, is it is iterating through every type of output that the function generates. So our function generates a list sometimes, and sometimes it generates a string. How can we fix that? So we have a list and a string. Let's think of a difference. How can we discriminate a list from a string? What's the difference between a list and a string? Well, the difference is clearly a data type. A list is a list object, and a string is a string object. So how about implementing a conditional here, which says something like this: if type of output is a list, then indent this with 4 spaces and that one as well. So this loop now is nested inside the conditional and will be executed only when this evaluates to true. So only when we have when we get returned a list from the program. So else, if it's not a list, it has to be a string. So in that case, we want to print out the output without iterating through it. So let me check. And we get the output correctly this time. The message, the word doesn't exist. Please double check it. Let's check another time with a correct word, and we get the correct definitions in there. Let's try another word, mathematics. And this time the mathematics word has only one definition, so we get the definition printed out in here. So it's a science. Let's try the other scenario as well, rain. Did you mean array instead? No. The word doesn't exist, please double check it. So we got this line here executed. So yeah, this is the complete code. And I think we can consider our program complete now. So that's what I thought of adding to the program. Now the program is quite user-friendly, and we are considering many scenarios there that the user may input to the program. However, the interface is still a command line interface, so it's not a desktop graphical program and it's not a web application. The interface is the command line, so you send input through the command line and you get output through the command line. And what I'm trying to say is that you can actually extend this program so that you can transform it into a web application where the user, instead of entering the input through the command line, they can enter input through a web page. So through a live website, they can enter input, push a button, and then get the output dynamically on the HTML web page. So that is possible with Python, but you're still not ready to do that because we have quite a few more sections to go. We have some applications where I'll teach you how to develop web applications with Python. And after that, you can go back to this code and extend it and create a web interface. And also you'll be able to create a desktop graphical user interface with the knowledge that you'll gain through these sections, because we're also covering graphical user interfaces in the course. And also we are also covering databases. So why I'm mentioning databases? Well, because in this program we're using this file where to store our dataset. The problem with this is that if this gets too big, for now this is just 5 megabytes, oh that's good, but if the file gets too big, then you need to load the file in Python every time you execute the script. Like here, we are loading the file into the Python session when you execute the script. Now, if the file is too big, that will be very costly in terms of time. So what you want to do instead, you want to use a database, maybe. With a database, what happens is that you make a query to the database, and instead of getting the entire dataset, you actually get only that row or that value which you queried for. So databases are very efficient. I will cover databases later in the course. And so after a few sections, I'll get back to this program. I'll give it to you as an exercise so that you can extend it by creating an interface, a graphical interface for that, or a web interface. And also I'll give you access to a database where you can query data for this program so that it becomes a real robust with a very friendly user interface. So I hope you like the idea, and I hope you are enjoying the course. And yeah, let's move on with some more sections. I'll see you later. Bye.